Okay, so first off, things that we need to notice. K is a constant. We've got t squared and r cubed. And as always, we are looking at three significant figures. So first off, filling in our table, we've got t on our first line and t squared on our second. So what that's trying to tell us to do is square the value that is in our t. So we start off with 365 squared, and this needs to be three significant figures, so this is 1, 3, 3 and 3 zeros. We then do basically exactly the same with the rest of it. So squaring this, we get 187 and 5 zeros and 116 and 6 zeros. This line is cubed rather than squared. From a calculator point of view, you've got a button that looks like the little up thing, and then we're on 338 with rounding. So we've got 3, 380, 000, 471, 1, 2, 3, 4, 5, 6. And the last bit's given to us. So we then use this information to be able to plot our graph, and we are plotting t squared. So this one is going on our x-axis and this is going on our y-axis. So what you'll find is you've got this one, which is miles out, and these two, which are very much squashed right at the beginning. So if we go for the last one first, we are looking at this going on our x-axis. This one was going on our y-axis, which we know from our original equation. So we've got a scale along here that's going up in 100 million. So we need 30 and then going up to 16. So we've got a first point that's up here somewhere. The next smallest one we've got, we are looking at 471. So that's going to be 4 on this scale and a little bit less than 2 boxes, going up to 18.7. So 4 and 2 boxes, and 18.7 is about here. And then we're down onto tiny numbers. So what we're looking at is putting it at 3, and realistically these two basically end up about here. You can't really see them. We then need a line of best fit. So stick a ruler straight the way across, and that will then hopefully give you a nice straight line. It should cross at 0, 0 because we don't have a constant here. And that lack of constant there tells us it's going to cross at 0, 0. We are then looking for part C at an average distance of miles from the sun. We know that this is going to be 228. So we know that for 1C, R is 228. But our formula is going to use, or our graph is using r cubed. So that's going to be 228 cubed. So 228 cubed is 11950. 119, 1, 2, 3, 4, 5. So on our graph, we are looking at going up at around 11. So we're looking at going up here. If we do that, we end up hitting there and going across. So using the line of best fit that I've got, that gives us a t squared value of about 41.5 million days. So that's that. But we need to find the orbit, so we need t, so we can square root that. 41, 5, 1, 2, 3, 4, 5. So we're looking at an orbit around 6,440 days. It's going to be around there. It'll depend slightly on what your line of best fit was. Okay, so part D, find K. K is going to be the gradient of your line. So you're going to need to pick 2 points on your line. Conveniently, we can choose the intercept, so 0, 0, and we may as well choose the one that's furthest away. So we end up with an x value of 3,000 million and a y value at 116 million. Luckily, these things cancel when we put them into a gradient equation. So for m, we've got the change in y. So 116, take away 0, and 3,000, take away 0. And that will give us our value for k, and that should come in at 0.0386 recurring. 0.0387. So part E asks us to use this value of k. So at that point we've got an equation that is t squared equals 0.0387 r cubed. And if we want this just to be in terms of t, then we've got to square root both sides. So we'll have the square root of 0.0387 r cubed. For part F, we are asked to use the model, not the graph. So this means we need to substitute it into our equation. R is going to be this number, so we're going to need r cubed. So from a calculator point of view, we need the square root of 0.0387 times 4497 to the power of 3. So this tells us it should have an orbit that is this many days. So part F. In an actual exam, they'll give you enough lines so that you can actually fit everything on. And in fairness, they normally give you far more lines than you can actually want. So 4, 4, 9, 7 to the power of 3. And that equals 5,